Engineered plant pots from plastic wastes and rice hull ash, basis for extension. Good day everyone, I'm Cheryl Salvan. My co-researcher Jan Rogel Ursua. We are from University of Antique, Sibalam, Antique, Philippines. This study focused on the utilization of the growing plastic and agricultural wastes in the province of Antique, specifically in the municipality of Sibalam, turning it into the engineered pots. We are in line with the United Nations Sustainable Development Goals, good health and well-being, and also to promote gender equality, decent work, and economic growth, especially to the women who have lost work due to the cause of pandemic 2019. And also the College of Engineering and Architecture of the university wishes to be in partner with a willing barangay to have this alternative source of income or livelihood aside from the usual clay pots and cement pots. Antique as of 2012 is composed of 37,000 hectares of farmlands according to Census of Agriculture and Fisheries, Agriculture 2012. Rice husk is an organic waste produced in large quantities which is a major byproduct of the rice milling and agri-based biomass industry. Plastic usage has increased in proportion to the growing population. The industrial-scale production of plastic began in 1950s and has bloated up to 9 billion tons of plastic as of 2015. In the 65 years, merely 9% of the plastic waste was recycled and reused, 12% incinerated, and the 79% used in landfills or landed up elsewhere in the environment. It takes more than 500 years to recycle plastic wastes, making this study sustainable. In order to build a clay pot, it is a natural resource in the municipality of Sibalam to use clay, but as the production is growing, so does the need for the clay resource. On the other hand, plastics are usually burned or buried. Shredded plastics have good characteristics such as hardness, flexibility, and is lightweight. With proper sizing and homogeneity, the expected strength can be attained. Cement as a binding material contains silica. Likewise, burnt rice ash hull is also high in this content. This study sought to find the effectiveness of the engineered pots by partially replacing rice hull ash to cement and shredded polyethylene terephthalate or PET bottles to sand. The study focused on the following questions. What is the proper mixture of materials in order to get the desired output in terms of compressive strength, water absorption, and fluorescence? What are the effects of varied concrete brick mixture on compression test? What are the effects of varied concrete mixture on water absorption? And what are the effects of varied concrete mixture on a fluorescence test? The methodology used was the researchers chose to make a big sample using 1 inch by 4 inches by 6 inches mold, had it cured for 7 days to undergo series of tests. The process of making samples for engineered pots includes the collection of materials, the cutting of the plastic waste into 5 mm to 10 mm rectangular approximate size, and the washing of materials, also including the 15 kilograms of the river sand passing the 4.75 mm to 0.075 mm CU. The preparation of materials, they were air dried and they have been weighed in a weighing scale separately. The fixing of proportion of materials as seen in table 1 and the preparation of the mold, the casting of samples, the curing, the testing, and the result and comparisons. As seen in table 1, the composition of materials by weight, the total weight of the brick is 1.8 kilograms. We have 4 brick codes from A to D. The Portland cement mass ranging from 39 to 45%. The sand mass is ranging from 49 to 55%. The PET and the RHA ranges from 6 to 0%. 3 samples were prepared for each brick code and has been subjected to the testing at the Department of Public Works and Highways for compression under the universal testing machine with a load rate of 140 kg per square centimeter per minute was applied gradually without shock and continuously until the brick specimen broke. Finally, each compressive strength of the sample was recorded, and the features of the failure of the bricks were also taken down. Moreover, the resistance for crushing varies. Say, for instance, soft-facing brick crushed about 3.5 Newton per mm squared until 140 Newton per mm squared for engineering brick. As shown on Table 2, the maximum load and compressive strength of various sample mixture. As the amount of cement and sand increases, the density also increases. According to ASTM C129 standard specification for non-load bearing masonry units for net area, compressive strength for the minimum requirements lower than ASTM C90, the compressive strength requirements are 500 psi for an individual unit and 600 psi for sample average of 3 units. Hence, all of the samples of the bricks surpass the requirements of 500 psi. As you can see, it ranges from 3309 to 1579. As the percentage of the RHA and PET increases, the compressive strength also decreases, but it is still surpassing the requirement of 500 psi because brick D is 1579.171 psi. In terms of water absorption, a concrete brick can absorb or discharge moisture content because of its dryness and porosity. The brick will absorb water if it is dry, thus making it poor, and the mortar will fail. It reduces the general strength of the structure. With this, water absorption test as per ISG 495 was performed. It is noted that the specimens were dried and cooled down at a room temperature before the individual dry mass was recorded using the digital weighing scale. Then, dried specimens are immersed in clean, fresh water at a temperature of 27 plus minus 2 degrees Celsius for 24 hours. After that, they had been removed from the immersion and any trace of water has been wiped out using a damp cloth. Then, this specimen, the wet mass was obtained 3 minutes after it has been removed from water. Bricks of good quality do not absorb more than 20% of the water. Lastly, the percentage of the water absorption was determined from the formula M2 minus M1 over M1 times 100. As you can see from the table, all of them are excellent because it has not surpassed the 20% absorption. So, although brick D has the highest among the four with a percentage of 4.167, still it is way lower than 20%. In terms of a fluorescence test, a whitish crystalline deposit of foggy salts or crystal bricks consisting of calcium sulfate, magnesium sulfate, and carbonate of sodium and potassium is called efflorescence. Sometimes efflorescence appears a few years after the end of construction, leaving the building owner to face questions about cleaning or maintenance. The water will tend to dissolve the soluble salts in the brick and transport them to its surface, where they may be progressively deposited as the water in which they are dissolved evaporates. So, the brick is immersed in distilled water for 24 hours. It proves that the absence of alkalis in the bricks is there. If the whitish layer is visible for about 10%, the brick surface, the presence of alkali is acceptable. If it is about 50% of the surface, then it is moderate. If the alkali presence is more than 50%, then the brick is severely affected by alkali. But as you can see, the fluorescence result is that it is acceptable, only showing slight presence of the 10%. In totality, the researchers have found out that plastic waste and RHA are effective to replace sand and cement in the sample. It is suggested that the mixture to be used would be that of brick tea so that more wastes could be included and lesser percentage for cement and sand to make it less costly to make. It has not absorbed more than 20% of water and shows that waste can increase durability of concrete. The presence of alkali was in an acceptable range too. Therefore, as to attain the same strength and durability of the sample, the engineered pots should also have the same thickness of 1 inch. Based on cost comparison conducted by the researchers between cement pots and the engineered cement pots, it was found out that the material cost was reduced by 12.28%. Therefore, it is economically at the same time eco-friendly. Therefore, the college can partner with the local government unit in Sibalom, particularly in Barangay Barit, to push through the extension project because of the availability of both the wastes and can help them have an income more than they are earning now because they will be using plastics and RHA as an alternative. Thank you.